All right, so we're picking up, this is part 2 of Algebra 2 review for test 1 through 30. And one of the things we want to go over is the difference or the similarities between y1 minus y2 over x1 minus x2 versus the other way around. Okay, so I'm going to erase some of this. Right, the other class gave us these numbers. So these aren't numbers on the test, but they're maybe similar. So the first step that I would have in here is y1 minus y2, right? And the reason we have y over x is because we want rise over run. Y refers to our up and down movement, x refers to our across, right, left and right. So that's why if we're going to find slope, we have to do y over x. You follow me? And the minus has to do with finding the difference or the distance between my y values and the distance between my x values. All right, so if I'm doing y1 minus y2, that's 7 minus 8, right? And then I would do x1 minus x2. That would be 3 minus 6, correct? All right, well, 7 minus 8 is negative 1, and 3 minus 6 is what, negative 3? Giving me a slope of 1/3. Give me a second here. All right, so we get a slope of 1/3 from 0.3768. Now let's see what happens if we did 8 minus 7 over 6 minus 3. That would be y2 minus y1 over x2 minus x1, right? Okay, what's 8 minus 7? 1. What's 6 minus 3? Okay, do I get 1/3 either way? Because it's the same line. Okay, you follow me there? All right, so let's talk about the rest of this question. The rest of the question wants to know, get the slope-intercept form of the equation. Well, I have the slope, right? I know my y equals 1/3 x plus b, right? I know that much of it. The rest of it I still have to find out. Mainly, I have to find the b, right? Because in the end, I don't need, my equation isn't going to include a different number for y or a different number for x. But in order to find b, I'm going to have to plug in one of these sets of x and y into either into this equation or into the y minus y1 equals m times x minus x1. Which one do you want to use? You want to, okay, so we'll just plug in for b here. All right, which coordinates do you want to use? And again, it doesn't matter because both coordinates are on the line. Both coordinates are a solution to the line, so it doesn't matter which set of coordinates you use. 3, 7. All right, so what number am I going to plug in for y? 7. 7 equals 1/3 times 3 plus b, right? And I'm solving for b. Okay? All right, what's the next thing to do? Multiply. So 7 equals, what's 1/3 times 3? 1. 1 plus b. What do I do with that 1? It doesn't cancel out, right? I got to subtract it. All right, so what does b equal? 6. So what is the equation of my line? Does that work? We get it? Okay. That's something that we can remember, something that we can do tomorrow. All right, let's move on to question number 12. Okay. Again, my object is not to try to force you to do something a specific way. It's to try to get you to understand how to do it. Okay. So here we want to find the excluded values of a rational expression. So I'm going to try to do this the best way I can, kind of making some things up. Well, let's say z squared minus 10n. Oh, sorry, let's do 10, stick with my variable here. 10z, and let's do this, okay. All right, we want to find the excluded values. All right, so basically what we're looking for is the domain of the function. All right, what can I not have? Because that's my excluded values. I can't have what? I can't have 0 where? Where is 0 not allowed? In the denominator, right? I can't have 0 in my denominator. That would be an excluded value. So I'm going to have to solve for what makes the denominator 0 so that I can say those things are not allowed. Okay? How do I do that? How do I solve for the zeros of the denominator? I got z squared minus 10z plus 8. How do I find the zeros? Factor. All right, so maybe something like this, right? What are going to be the first terms? I know I'm going to get z. I'm going to get z. All right, it's minus plus. So what? That ought to tell me something about the kinds of signs that exist in there. There's only two. Okay, we do know, hopefully we know, that this is always produced by the multiplication of these two things, right? We're aware of that? Yeah. All right, and the fact that this is a plus tells me that there's only two ways to get that, right? Because I'm multiplying. There's only two ways to multiply two numbers and get a positive number. What are those two ways? Multiply two negatives or multiply two positives. And the fact that this right here is a negative tells me, am I going to be multiplying two positives? Because this tells me I'm adding or combining those two things. So what do the signs have to be? I got to have a negative here and a negative here. All right, so that's critical thinking, right? I'm trying to think ahead and how to set this up. So now what I'm looking for is numbers that multiply to be 8 but add up to be 10. And like I said, I made this up, so I don't know how well this is going to work. I may have to change that middle number to something else just to kind of make this work a little bit better. Let's say let's change this. Let's change this to a 6. Okay. Yeah, if we change that to a 6, because I'm just making this stuff up anyway. I'm not making up the math, but I'm making up the problem. Yeah, none of this math that I've been telling you is real. It's just stuff off the top of my head. All right, so we should get 4 and 2 down here. Now, have we solved for the zeros yet? No. How do I solve for the zeros from here? Z minus 4 equals 0 and z minus 2 equals 0. Okay, what do I do over here? Add 4 to both sides. So z equals 4, and over here, add 2 to both sides. Z equals 2. So I know that we solved for z equals 2, but what we're really saying is that z cannot be 4 and z cannot be 2. Okay, those are excluded values. Does that make sense? Okay, we can do that. All right, let's move on to number 13. Okay. All right. This one's a little tricky. All right. It says that the area of a rectangle, so okay, is equal to something along the lines of, and again, I'm going to have to just probably make something up here. All right, that this whole area here is x squared. Let's see. I don't know. Think that'll work. So the whole area is equal to that in square units. Okay. If I know that the length is this, okay, we want to find the expression for the width. So yeah, there's a couple of things that you could do, right? So we could use synthetic division here, where we're saying 1, 7, and 10. We know that x plus 5 is a factor, right? So what would I divide by? I divide by -5. That's In case you're wondering, that's x plus 5 equals 0, so x equals negative 5, right? Does that make sense? So we're plugging that in here. What do I do with the 1? Drop it. Negative 5 times 1. I feel like I'm talking to a dog. Drop it. Drop it. Okay. All right, negative 5 times 1. Okay, comes in there. 2, negative 10, gives me 0 as a remainder. What do I do with this 1? What does it become? Well, it was represented, this 1, 7, and 10 was representing x squared, 7, and 10, so it becomes just x, right? Plus 2. Okay, now I will warn you that the area that you're seeing right here is more complex on the test. Or not necessarily more complex, it's still an x squared plus something, but it's bigger numbers, right? Okay, this middle number and this number off here are going to be a little bit bigger. But could I still use synthetic division to solve for the factor? Yeah, because I will tell you that the length is similar in nature to that. Okay, so if I solve it, set it equal to 0, right, use synthetic division, I could do that, right, if that makes sense. Okay? All right, we feel comfortable with this? Okay. All right, let's try 14. Some of these takes me just as long to kind of create a question as it does to answer it. Let's see, this next one is really just the combination of like terms. So I think this kind of almost goes back to question number 1. If I had something like, let's see, it's hard to read. Are you all right? Like you're trying to start a lawnmower over here. Okay, you're going to get something like that. In the end, what am I trying to do with this? Combine like terms, right? And they're going to try to throw you for a little bit of a loop by showing you x, y, and yx. Are those still like terms? Yes, right. They're going to try to throw you for a little bit of a loop by getting you to subtract a negative from a negative, right? Negative 16y or y. Negative 20y, okay? So don't get lost in that. And then they might try to throw you for a loop by, giving something with no like term, right? Okay, so doesn't mean, just because it's easy doesn't mean you'll necessarily get it right. Okay, 15. Okay, we want to know percent change. Percent change, let's say from 120 to 90. What is the percent change? Just where things begin to double back. Like even if we don't finish, we've already covered a lot of these types of questions in the first video. But percent change. Minus original divided by original. So what's the new number? 90 minus divided by, okay? So 90 minus 120. Right, should come out to, negative 30? Negative 30 divided by 120? Negative 1/4. So a decrease of 0.25, is that what you said? But we want that as a percentage. So 25% decrease. Okay. All right, so beware those. Let's see. You need to solve. It says to solve a system by graphing. It's going to give you something like 6x plus 8y equals negative 72 over negative 4x plus 8y equals negative 32. It says solve by graphing. If I was going to solve these by graphing, probably what I want to do is convert both of them over to slope-intercept form, okay, and look at the graph that's going to match the slope and y-intercept of them, okay. Granted, it's set up so that I would naturally solve this by using elimination and solve for the x, y, where they're going to intersect at. But if I know where they intersect, but I don't know what the slope of each of them is, could I still get it wrong? Yeah, because just because I know what x and y are, where they intersect, doesn't mean that I know what those lines actually look like. So be aware of that. Okay? All right, 17. Okay, good. We get another absolute value question. We have like 12x plus 18 plus 10 is equal to 4. Now, the biggest mistake I'm seeing you guys make with these absolute value questions is that you solve them once. How many times do I have to solve an absolute value equation? Twice. Now, there is an inequality question on the other video. So not only do I solve it twice, but I flip the inequality symbol whenever I do that, right? So, but before I do any of that, what do I have to do? Subtract 10, right? So I'm getting, 12x plus 18 is equal to -6. Well, let's see. Is there a solution to this? Is this possible? No, because this is still an absolute value, right? Can an absolute value equal a negative number? No. So maybe watch out for things like that. If it did say 6, though, let's say it comes out positive, right? I'm going to do 12x plus 18 equals 6, and 12x plus 18 equals -6. So be ready to do all of that, okay? And be ready, it might be no solution. That's a possibility. Okay. 18. It's going to give you a complex quadrilateral. Okay. Something like 4x squared minus 56x plus 196. What do I want to do with this to start with? Divide it by 4, right? Divide everything by 4. That's going to give me x squared minus something plus something, right? I don't know what those things are. Okay, but in the end, now what I do want to know is that I have factored out a 4. Okay, what do I get in here? 14 and 49 probably, right? Okay, so in here, right, I've got an x and an x. Out here I've got a 4, right? Should be what signs? Negative, negative, what and what? 7s, all right? Well, that's, if I really want to simplify, that's x minus 7 what? Squared. Okay, so I might see something like that. Okay, do we get the steps to getting there? Okay, be aware of those. 19. All right, this is real similar to a question you had up on the board, so I'm not necessarily going to go through all this, but let's say we have a slope of 6 and points at 6 and 20. Okay, can we write the equation of that line in slope-intercept form? Okay, good. Okay, last question. Let's see. It's going to give you something like 6x plus 7y minus 8z equals 20. 4x minus 2y plus 4z equals 15. 3x plus 5y minus I don't know, 9z equals 6. Okay, what is the solution for x, y, and z? Do we know how to do these? and it's going to give you your answer will be right there. That's what I'm telling you to do, is to set it up as a 3 by 4 matrix, right? And then go in and hit RREF. Do we remember how to do this at all? Okay, if you don't, you want to ask somebody that knows how to, okay? Okay. Can you solve this pencil paper? Yes. It's the last question in your test. Are you going to have time to? No. Okay. I want you to know how to solve it. Okay. Sometimes you don't have all the time in the world to do everything the way that even I would like you to do it. And so here you go. RREF. There is a difference. Okay. I'm going to hit stop on that, and I'm going to send you guys the video.